Good evening, my YouTube viewers. Crystal here. What I'm doing is I'm giving you a video on a program that I wrote today because I've been busy writing programs. And basically what it is it's how to set up CatBoost for a class imbalanced binary data set. And what I've done is I found a data set on Jason Brownlee's site, which I downloaded from his personal GitHub account. So I didn't have to download the file myself. And I'm using that. But unfortunately, it doesn't have as good of a class imbalance as I would like for it to have. But what we're going to do is we're going to go ahead and go through the procedure of how to set up CatBoost for a class imbalance binary data set. So the first thing that I did was I opened my program in Google Colab, and I wrote it in Google Colab. Google Colab is an online Jupyter notebook that you can write programs in Python with. And so I've got in the remarks section, this is an example of how to deal with the binary class imbalance progress in CatBoost and also logistic regression. So what I'm going to do is I'm going to make my model in CatBoost, but then I'm also going to make a model in logistic regression, and we're going to compare the two. And the reason for that is because anytime you're working on a program or you're working on any program, what you need to do is you need to try it out on several models to see which model gives you the best outcome. And so as we go through this program, you will find out which model is going to give us the best outcome. Excuse me. So the first thing we do is we import our libraries. The thing about Google Colab is they've got most of the libraries already installed, so you don't have to install anything. But you still have to import. So we've imported Pandas, NumPy, Matplotlib, and C4. And then the next thing we're going to do is we're going to load our data set. But we have only one data set to load up. And this is a small-ish data set because it's only got 1,000 rows and 21 columns. So it's smaller than what I'm used to working with. Now this particular data set doesn't have any headers, so you have to set it up here for headers equals none. If you don't set it up for headers equals none, then the first row will be the headers, and you don't want that. So we do an info, a train info to see what we actually have in this file. So we've got several object columns and several integer columns. And what I had to do was I had to write down which columns were object and which columns were integer or numeric, because I was going to need that later on when I was writing the program. So we check for any null values. Fortunately, in this instance, there are no null values to check for. And we performed a graphical representation. So I used a group by to get a graphical representation, and I also used a group by to find out that number 1 was 70% and number 2 was 30%. So it's not really a massive class imbalance, but it's still a class imbalance. And then so we've got our graphical representation of 70% and 30%. Now what we've done is we've defined our X and Y values because we don't have a test set. We only need the 2 values. So Y equals train, and that's row 20, column 20, and X equals train, drop column 20, axis equals 1. Now we've got a column transformer, and the best thing to do with the column transformer is you put in x.info, and that tells you what all the columns are, because you're going to need that information when we build our column transformer. So we built our numeric features. Our numeric features are numeric columns, being 1, 4, 7, 10, 12, 15, 17. They go through a pipeline. They go through an iterative imputer, random state 1, and they're scaled in the standard scaler. And then the object columns go through a categorical features, being 0, 2, 3, 5, 6, 8, 9, 11, 13, 14, 16, 18, and 19. They go through a simple imputer, because categorical features can't be imputed through the iterative imputer. And then they get one hot encoded for their categories. Then they go through, then I created a preprocessor. The preprocessor has the numeric transformer and the categorical transformer in it. And now what we do is we split X for training and validation. So X train, X val, Y train, Y val equals train test split, X, Y, random state equals 1, test size equals 0.1, shuffle equals true, stratify equals yes. You need to have stratify set to yes, so that it'll know that it's a class imbalance. So you have to set stratify up to yes. And then you set shuffle equals true, so it'll shuffle it. Now what we do is we create our pipeline. And the thing is that CatBoost is not installed on Google Colab, so you're going to have to install it on Google Colab. So we've got pip install CatBoost. Now we set up our model. So we import pipeline, and we import CatBoost classifier. Model equals pipeline. Steps equals preprocessor, because we created the preprocessor earlier with the numeric and the categorical features. And we've got CatBoost classifier, and we set our class weights up. How you set your class weights up is every class, every weight is 1 minus the percentage that it holds. So number 1 was 70%. So 1 minus 70% is 0.3. And then number 2 was 30%. So 1 minus 30% is 0.7. And so that's that right there. And then I just experimented with the iterations to give me 500 iterations. Learning rate equals 0.1, depth equals 5, and random state equals 1. Model fit X train, Y train, and then we print our score. So we go down here. What I'll do is I'll do this. And then we had a score of 100%, so that worked. And then the next thing we're going to do is we're going to predict on our validation set. And when we predicted on our validation set, we only got a 72%. And so I gave you a graphical representation of that. So this is what you came up with. And then what it counted it. And so it was 66 ones and 34 twos, and you were supposed to have 70 ones and 30 twos. And then I created a data matrix. So the data matrix is you had all of the ones and twos covered, so that was good. Now what we're going to do is we're going to compare CatBoost to logistic regression. And you have to keep in mind that every time you're working on a project, you need to test that project out on several models and use the best model. So model equals pipeline. We've got our preprocessor. Our regressor or our classifier is logistic regression. Class weight is balanced. Max ITER is 500. random state is 1, and solver is libliner. And I got an accuracy of 75, and I had to play around with the parameters to try to get up to 75%. So that's one thing that you have to do when you're working with these models. You also have to tune the parameters, because if you don't tune the parameters, you're not going to get an optimum level. So now we predict on our validation set, and we only got a 71. So with CatBoost, we got a 72, and with logistic regression, we got a 71. So in this instant, CatBoost was the better model to use. So we put it up on a graph, and you can see that there's not a lot of difference between 1 and 2. So 1 was supposed to be 70%, and 2 was supposed to be 30%, and that didn't happen. We put it on a counter, and 1 was 53 and 2 is 47. So you can see there's not much of a difference. So it didn't do a very good job of balancing out. And then we put it on a confusion matrix, and so you can see the confusion matrix as well. So that's it. That concludes this this program that I wrote, and it's a small-ish program, but what I wanted to do was I wanted to illustrate how to set up CatBoost for a class imbalance. And so I didn't want to use the data sets that I'd already been using, so I just used a data set that I got off of Jason Brownlee's site. So that's all I did. But this program is on my GitHub account. You're more than welcome to get it out and use it if you want to use it. I'm going to be making a blog, and when I make the blog, I will give you a link to my GitHub account and links to everything else. So this concludes my presentation. If you like it, please like, subscribe, and share. If you like the work I do and want to leave a donation, I've got my email address to my PayPal account in the description box below. And I don't have enough subscribers, so I have to ask for donations. So thank you so much for watching this video, and I look forward to making more videos for you.